Hi everyone, this is the introduction to Unit 8 Mammals. We're going to talk briefly about the evolution of mammals and a bit about the adaptations found in mammals. So let's start with evolution. Their lineage is very closely tied to reptile lineage, bird lineage. They have vertebrae, bony skeletons, four limbs, just like the reptiles do. An amniotic egg, which was a huge development. However, they have plenty of very distinct features. Obviously, the hair is the one go-to, but with fossils, you're not always going to find the hair. So one of the big major differences that they look for is in the skull. It says here, two post-orbital fenestrae. And that's referring to the holes that occur on the outside of the skull, where reptiles are going to have two holes behind the eye, but mammals aren't going to have that. They're only going to have the one. So that's something that they can look for. And some of the fossils that we have found, including some like these guys, were often some more reptilian than others. Some eventually could be found with hair, but it ties our early mammalian lineage to these large reptiles that used to exist, and early mammals were likely to be these fossorial, tunnel-digging types of reptiles, with whiskers probably being some of the first hair that developed. So using the skull fossils and the occasional hair, we were able to put together a good lineage of how mammals transitioned from early reptiles. But this has all been fairly recently in the development of diversity on Earth. So all within the past 500 million years, with the extinction of the dinosaurs at the K2 boundary 65 million years ago, really opening up the window for all the diversification of mammals that we see today. Whether it's everything from the carnivores to primates to elephants. We'll get more into the classification later, but the first adaptation to talk about would be the fur. It evolved from scales just like feathers did, and has many different uses, whether it's for senses or helping to regulate the heat of the animal. And there's many different types of fur based on the thickness, how many pieces of hair are on the same follicle. So they can be quite varied. But it's going to really help aid in thermoregulation. And other than a few other animals, birds, sharks, mammals are going to be the major group of warm-blooded or endothermic animals. They can create their own heat and maintain it. It gives them a great advantage in colder environments. And this is one of many methods of maintaining homeostasis in the body. And one of the best things that has made us so successful, especially in the early parts of our development, in diversifying and evolving and surviving. There are three major types of reproduction found in mammals. The echinoderms is one of the smallest groups. They have all kinds of really unique features, including the duck-billed platypus, who not only lays eggs, but he also has a duck bill. He has venom barbs in one of his claws. But these guys are one of the oldest lineages of mammals. The marsupials and the placental mammals, they give live birth, but they do it in slightly different ways. The marsupials have that pouch, like a kangaroo might have, that the very small developing babies are going to move to and grow up in. Whereas placental mammals have this placenta that helps to continue that growth within the body instead of outside in a pouch. tied with reproduction is going to be the mammary glands. Huge success. It makes a lot of these animals part of that K selection species where these adults, these parents are going to actually care for their offspring, unlike a lot of fish or reptiles where they lay the eggs and then there's not much else that they do. They might lay a lot of eggs and then they go off and die or live their own life, but mammals will rear their young, and all of them are going to have some sort of mammary glands, even the echinoderms. But they vary in a few different ways, such as the number of nipples. Teeth is a surprising thing that's so different in mammals. Mammals have a diversification of teeth that really isn't found in many others. We talked a little bit about how shark teeth can be serrated or pointed, but still not a whole lot of diversity found there. You can see this crocodile mouth. All the teeth are relatively the same. But with mammals, think about your own teeth. You've got the flat ones in the front, the sharp ones on the side, and the grinding molars in the back. So they really diversify based on the kind of function that they're performed for. Ripping and tearing flesh, grinding vegetable materials. That's going to be really consistent between herbivores and carnivores. The long teeth found in rodents, the filtering teeth found in whales. That's what cetaceans mean here. And even tusks. And there are many behavioral adaptations found through our mammals. Lots of reproductive courtship type behaviors, like the rut performed by these deer here, fighting for the right to mate with the females, and hibernation as well. True hibernation is going to be found more in rodents, and not like bears that you might think. There are different levels and versions of hibernation, and not all of them are considered true hibernation. But I hope this was interesting and helpful, and thank you for watching.